question. Let's talk about constructing equilateral triangles for a bit. So actually, let's not talk about it. Let's just try to do it. How in the world could you fold an equilateral triangle?
Can we know anything about this?
It is square. So you're trying to get some different angles. What angles have people figured out that they can fold? Or what you do, sort of? You think you can do 60 degrees?
Well, if you fold this into thirds, I mean, it's not exact though, which is the problem. So I made an almost equilateral triangle. Look at my almost equilateral triangle.
So you sort of eyeballed it, right?
Yeah.
And tried to get it kind of in thirds and adjusted and tweaked and okay. But then from there you're like, okay, 60 degree angle.
Once that happens, it's so easy because anywhere along here it's going to be, if there's a 60-degree angle, then these two have to be equal, and so it's voila, triangle. But
what properties do 60-degree angles have, or what things have you been, Chris, you've been jotting things down. What have you been jotting down?
30, 60, 90 triangle.
Okay. Why?
Because if I put two of them next to each other, then I have an equilateral triangle.
Okay, so you've been thinking about a 30, 60, 90, about it like this, and whether if you could do this, then you could do that.
Mm-hmm.
Okay. And what did you note about it?
Base, you're going to have 1, hypotenuse is 2, and height is √3.
Okay, does everyone know where that came from? Is everyone good with that? Okay, so 1 squared root 3 and 2. So if you could construct something like this, you'd be in good shape.
But wouldn't you need either a ruler or a 60-degree angle? Because we have a 90-degree angle, no problem. Or I guess if we knew that something was twice as long as something else.
That's what I was thinking.
Well, what would have to be twice as long as what else on the paper? So what was your idea, Peggy? What were you?
Well, if you have the square
folded
in half, you got half. You got the 1 and the other like this, the 2. I would just go like this. Cheating.
No, that's not cheating. Go ahead, do it. Start with
You could
that.
fold that if you wanted to. Right, that's what I was going to do. But
So where would it have to go from and to?
from the center to this place that I marked, which was the length of 2.
From the center up at the top, you mean, or something, or?
Yeah.
So if you draw,
Is it really an idea? I just said, oh, if I folded that in half, I'd have a length of 1 and a length of 2. So I just marked the length of 2 over here, and I'm going to fold it, but that's kind of like cheating.
No, I don't think so. I mean, go for it.
I don't know.
Sometimes you have to cheat first, but then we'll figure out a way to do it.
I just want to get a 60-degree angle.
Yeah.
That's what I want to do.
Yeah.
And then cheat some more and put it on another thing.
Sure. But the question is, can we do
When
it
you fold
precisely
this-
without the? Because you're right. If we could
would
sort of
fold
just
it there.
eyeball
Okay.
the trisecting angle thing, then that's a solution. That's good. But we'd like to do it without the eyeball. We'd like to actually construct it. I think we had last week the stabbing it through the paper axiom or something. So maybe we need a for that.
Apparently there's an axiom that lets you trifurcate an angle, and then everything will be all happy.
We actually don't need that axiom though. For this. We don't. We can accomplish this with nothing more than our axioms we had last time.
All right, there we go. Look at that. Isn't it lovely?
I don't know. What is it?
It's
What
an
did you
equilateral
do?
triangle.
Well, what did you do?
I folded a paper in half
Okay.
because that's how I make Sonobi units, and I like making Sonobi units, and I was frustrated. And then I folded in the half and half.
Okay.
Once again, the same thing.
Good
And then I did it again.
Fold it in half and half and half?
Yeah, so I have a little eighth, just because.
Just 1/8?
Yeah.
Okay.
So I have 2/8 and a fourth and a half.
2/8
And then
and a half.
those 2/8, because an eighth is half of a fourth, so you can take the fourth bit and put it up until it touches the eighth line.
Okay, you're going to
So
have to
the-
tell me how you did that. What?
So you
Why don't you
have
come
something like
up
this.
here?
Sorry.
Show us how you did that.
So if you have something that looks like this, you've got this part right here, and there's this distance between these two, and this distance is twice this distance. So
do you
the little...
want to draw it for us or something?
Yeah, sure. Hang on a sec. So you've got a whole, you got a half, and you got a half of a half, and you got a half of a half of a half. So this bit right here is 1, like that one. Well, actually, like that one.
Okay.
Which makes this whole thing be 2. So you just take this point and you fold it up.
Fold it up to where?
To the line right here. To this one. This one.
Oh, should be the other way. What if you do this?
So then when you fold it up to where it touches the line, then you've got something that looks like that. So that this goes over there. And then once you got that, it's easy enough to just make the same thing up.
So, what axiom is that?
Hang on, I'll get back to you.
We have some sort of general, we have the pencil stabbing
Oh, right.
axiom.
Axiom.
Basically that we can mark a point through another layer.
Right.
Right.
Oh, so that's what she's doing then.
So that's just sort of general ground rules, really. You had the
Corner, that point.
you had the idea that you can fold a point onto another point. We had another one that we can fold
the only one that you could actually get this point here.
the line through 2 points. What else did we have?
You
Form one line onto another to form a new line,
So you can,
which
L onto M to form a
we
new
can
line.
prove bisects the angle between them.
right. So you can fold a line onto another line. And what was another one that we had?
Point points P and Q in line L. You can fold P onto L, so the fold passes through Q.
All right, so if you have a point P and a line L and another point Q, you can figure out a way to make this touch this line so that the fold line passes through here. So I think it's going to be like this. So that P goes down to L and it passes through Q. Okay, and what else? I think we had one about a perpendicular.
Oh, right. If you have a line, you can make another line that's perpendicular to it. If you have a line and a point, you can make another line that passes through the point and is perpendicular to.
So you can fold you can fold the line onto itself so that the fold line passes onto it. So which axioms did Andrea use? Can we do what she did axiomatically? So Andrea, first of all, help everybody understand what you did if they're not sure.
well,
Okay.
So you take this paper,
Okay, start over. Piece of paper.
fold it in half.
Okay.
And then you're going to fold one of the halves in half, again, lengthwise. So now you've got, let's call this 1, and this 2 the lengths.
1, 1, 2, yes.
Okay.
1, 1, 2.
Down there on the triangle, the bottoms are 1 and 1, and so you've got to have the 2 be a side. Now the sides touch this middle, the axis symmetry. So you've got to have this side fold up so that it touches axis symmetry. There's just one point where it actually just touches.
So you're taking
So-
this point and what are you doing with it?
You're making it touch the center line between the two ones. Yep, that line.
Okay.
But it has
So
to-
that what?
So that the point between the 1 and the 2, yeah, that point has to stay where it is.
So let's call, which one do we want to call? Give me some letters.
Make A the point between 1 and 2, and make B the other point,
Uh-huh.
and make line be C in cursive, because lines are cursive.
Which, this
The
one
line,
right here?
yep, that's the symmetry line.
Okay.
So B has to touch C without A moving. And it has to just touch it.
So you want to fold the line so that it passes through.
Yep.
Something like this.
And then once you have that, it's easy enough to do the rest.
So what move is that?
This
Actually, what moves
fourth.
did she do? What did she do first? What was the first thing she did? Which axiom
Fold the
did she
paper
use
in
when she
half.
did this?
That's why I'm stuck bisect.
Which axiom lets us do that?
Um,
Line L and a point P.
The fifth one?